Thanks everybody for joining on this Sunday. I see some familiar faces. Ella, how's it going? And some new faces as well. So thanks everybody for joining and participating in our second MLOps World Conference. Very excited for this one. It's a smaller group, which is good. It's going to be nice and intimate. And you'll have some time for questions along the ride. And I would really, at this point, like to introduce Mohamed. Mohamed is a friend. He's somebody that's been doing some really interesting work for a long period of time. I would say long in terms of machine learning, at least. So he's got some really great practical experience, and I'm glad to have him deliver this presentation today in this workshop. Mohamed is a results-driven machine learning engineer and MLOps specialist. He's got 8 years of experience in machine learning and data-related fields. He's trilingual, he's a consultant, and he has a very wide range of project experience for various industries. Mohamed has been, as well, a director of data science and AI at a startup in Montreal. And with his experience on the field as a manager, Mohamed is capable of supporting all organizations in their AI project implementation, which he's been doing, and I know this personally, he's been doing successfully for a long period of time. Mohamed is also the author of a book, Data Science Pocket Guide, an instructor and mentor at the University of Austin, Texas. Mohamed, thank you so much for joining, and I will pass it over to you.
Thank you. So welcome, guys, to this session around the Kubeflow pipeline. I thought a lot about which tool or approach should I present that actually could be helpful for you in your MLOps journey. And I think presenting Kubeflow will potentially help you, especially that this case is more than just, a one-on-one case. It's really a case where we will potentially have a little bit more sophisticated architecture. The first thing is there is definitely a requirement for this workshop. You need to have a certain minimum knowledge of Kubernetes and virtualization. You need as well a knowledge of Python, because we will be reading and exploring some Python files. If it's not the case, that's fine. I mean, you can still watch this and try to understand the content and the approach. That's very fine. Obviously, I'm here to answer all your questions. That's my priority in my very limited knowledge, or at least what I know. And yeah, we will be working today on AWS. So if you don't have an AWS account, get ready, please, to create one. And I prefer using your personal account. Please don't use your corporate or company account, because usually there are a lot of restrictions in terms of what you can start in your company account, and we want to move fast, so we don't want to waste time when it comes to potential restriction that you might have. So you already had an introduction about me. I think I'm not going to repeat myself. I will maybe take a couple of seconds to talk about my book. Have a book, will be available on Amazon potentially next week or the week after, called Data Scientist Pocket Guide. At the beginning, maybe last year, I wanted to write a book, but the thing is, at the beginning, I want to create something hands-on, like a hands-on book to basically help future data scientists, for a specific tool or something like that. But then I realized a hands-on book is something that is already available in so many ways for people. So when I thought about it, one of the pain points that I identified in people learning curve is the understanding of the concept itself. I mean, I did have people in my team with very few experience in data science. They used to learn very fast how to apply a certain, let's say, a machine learning algorithm or a statistical tool. But when you start discussing about the what's under the hood, how it works, what you should understand from that, you see that people, they might have a lack of understanding of what's behind it. And that's what I did in this book, is basically defining and explaining concepts, how this algorithm or how this statistical theorem work potentially, what's behind it, how to do the potential interpretation of it. So I'll talk very quickly about my company. I have to because I'm an entrepreneur. So like David said, I'm a consultant. I have my own shop, and basically we help customers across North America, basically for helping them implement best practices in majority of cases in machine learning operation. We do the consulting, the services. We have three ways of approaching this. Either we work from the consulting side, so really drafting strategies in AI, or we support basically building machine learning, pure machine learning project. And what I do in the majority of cases is everything MLOps related. So support companies in drafting through best practices and potentially help them create environments, because that's something can get very complicated, is decide which environments are more suitable for me depending on the use cases that I have. So for the MLOps, this is important. The way I usually work, I have a philosophy close to coaching. I prefer coaching than just, delivering something and, having a hands off and then, do whatever you want with it. Because usually I do believe with the proper training and the proper coaching, you can enhance the team capabilities and help the company actually be more autonomous and have the ability to continue potentially to grow within such a field like MLOps. So this is a couple of interesting things. It's relevant to discuss about it, but I rather maybe show you some architectures and potential designs. So this is obviously pure open source. Here I'm showing you a design of a machine learning operation environment, purely open source. Here it's focused on microservices deployment with the CI/CD based on a lot on Kubeflow, on MLflow and GitHub. And Kubeflow here plays a role for retraining pipelines, crossed with Celdon, which is a tool that I appreciate much. There is as well another workshop about Celdon the upcoming week. Even if it seems complex, I definitely believe that this is not a complex environment. I've seen more complex than this, so more granular as well. So this is like, I would say this is more like a 3-4 out of 10 in terms of complexity. But again, I have this question sometimes. People, they ask me, is open source better than commercial solution in machine learning operation environment, either for experimentation or production? I usually say that open source is cool because you have a lot of flexibility, but it's hard to maintain. You need resources to maintain it. You need people to, you need a team, actually. You need a proper team, and sometimes can become complicated to scale as well. Commercials at the opposite, you have maybe less flexibility. You might have features that you think you really need that are not available in the commercial solutions, but that's the thing, you need less resources. So there is, you need to find like, you need to build up your business case and really understand what is more suitable for your company strategy. Here, this is not supposed to be microservices. This is more like a stream environment, deployment in streams using Kafka. And here it comes with a deployment, a retraining potentially strategy, or you can use something like online machine learning to do at the same time the training and the inference in production. Some of the tools and technologies, I mean, MLOps is one of those fields where tooling is very important. And there are so many tools to support the operation of machine learning, and all sorts of categories as well, from the end-to-end commercial platform to the open source experimentation, tracking, and versioning. And that can be tricky a bit, because sometimes you feel you fall in love with the tool, but then you realize that for your use case, there is a better tool. Yeah, I mean, I would say really the tooling at the end of the day is important, but not that much, because what matters really is your ability after that to basically manage that solution and maintain it potentially. So quick introduction to machine learning operation. And I like interactive sessions, so I don't like talking and talking and talking. So let's ask you guys a question. For you, what is MLOps and why do you think it's necessary? And by the way, there is no perfect answer to this, because the machine learning operation or MLOps definition might vary from an individual or a company to another. So let's see maybe what Carolina Beretta has to say about MLOps. What is MLOps for you and why it is necessary? Okay, let's see if Jack Jin has maybe an opinion on that.
Yeah, I think MLOps just we can leverage the DevOps concept and the idea and the techniques and apply to the model training and deployment and serving the workflow.
Interesting. I like the fact that you compare it to DevOps, which is interesting as well. Let's now see what Ella Chen has to say about what is MLOps and why it is necessary. Ella, yeah.
Yeah, on that front, I agree with what Jack said, because it also kind of fits into our company situation, also not me being lazy. I think what I wanted to add is it's the entire life cycle of ML models as well, like from maintaining and detect when you need to retrain, yeah, like when you need to redeploy your models, and also how do you scale your serving based on needs. Like, do you need to run batch jobs? Do you need to run like real-time inference?
Awesome. That's actually great. I like the definition as well of MLOps as the management of the life cycle of machine learning. I do believe that's very representative definition. And something very tricky is that MLOps is not really a job. It's more a practice. So our intervention is really like overviewing all the life cycle at the end of the day, which requires potentially different expertise. That's why I consider MLOps as hard or even harder sometimes than what we do in pure machine learning development or data science, just because it requires not just a knowledge in machine learning, it requires as well a knowledge in DevOps and potentially in other specialties that are necessary for you, like your ability to program, and you have to program efficiently because you have to automate things. There is a requirement in a lot of cases for automation scripting. So you really need to have the ability to automate things and have like a good level or good knowledge in programming, and this make it like even as hard or even harder than what we can do in data science potentially. Yeah, that's really one of the myth that you hear a lot about, is the fact that machine learning operation is just about the production or deploying the model. First, like you probably know, there are so many steps before getting in the deployment. before you reach the deployment, there are so many steps before that. And in addition to that, you have as well, and this is something a lot of companies they forget about, is in the scope of the machine learning operation practice, the experimentation. They are responsible for the overview of the experimentation, not doing the experimentation, but the overview of it, including the management of the environment. So the environment, the experimentation environment, MLOps practice is responsible for it. Oops. Yeah, I like the fact that Jack compared it to DevOps, except that, you know, there are common things, but we don't do it at the end of the day the same way they do it in DevOps for application or stuff like that. But steps like continuous integration and continuous delivery are here. In addition, usually they add up as well continuous training to the MLOps practice. So let's dig in a bit in some of the tools that are mandatory in your journey in MLOps. I mean, if you want to start somewhere, learning how to potentially support the MLOps practice, you definitely need knowledge in something like Kubernetes. I mean, more and more environment run on that. In machine learning, you need to run on that for scalability reasons, and a lot of toolings, I would say the majority of the good tools are available on Kubernetes. Very quickly, Kubernetes is basically, I would say, the top of the mountain of virtualization. I mean, the day I discovered Kubernetes, I was like, oh man, this is awesome, because you don't have to manage the virtual environment. It does the orchestration for you. So at the end of the day, yes, the only thing with Kubernetes is on the cloud, it seems easy, because you just launch like EKS cluster and or whatever cluster, Kubernetes cluster, click, and then that's it. It's available for you. But being able to install Kubernetes, that's another story. And usually no one does that. They use like Kubernetes as a service tooling like Rancher or potentially OpenShift and stuff like that. But yeah, I mean, definitely if you are starting your journey in MLOps, please take the time to really learn Kubernetes, learn how to use it, how to deploy on it, because it's very, very, very important. Now we can talk about Kubeflow. Kubeflow, what is Kubeflow? Kubeflow is actually a tool, I do believe it has been developed by Google, open source, obviously. It's a toolbox, actually. Today, we will be using a portion of Kubeflow called Kubeflow pipeline. But Kubeflow as is just a framework that actually includes a bunch of tools that will help you deploy those tools from the same configuration file to inside the same namespace in your Kubernetes cluster. So you end up like with Argo, with Seldon, with Kubeflow pipelines, TensorFlow, TensorBoard. So every tool that you might need, you can make it available. Obviously, it has to be supported by Kubeflow, but that's that's Kubeflow and why it is interesting usually for machine learning operation team. It's my personal experience. It's good. It's a good tool. The pipeline portion, you can compare it to what they do in Airflow. If you know Airflow, Airflow is another alternative for creating pipelines in the operation aspect of it, except that Airflow is more generic. Airflow can be used for whatever pipeline you want. Kubeflow pipeline has been created in the purpose of machine learning. That's the main difference between both. I'm not going to tell you one is better than the other. I will, if you are starting your journey, I advise you to know both, because I'm speaking with different companies, as a consultant, and sometimes they have Airflow, sometimes they have Kubeflow. So knowing both of them will be more than helpful for you later on in your journey in MLOps as a resource. All right, so now we can discuss about our use case today, and then we'll jump in the hands-on workshop. So our use case is actually quite cool. It's inspired by Kaggle, a Kaggle competition posted a couple of, I would say, years ago, maybe. And basically, the idea is in Reddit, you have comments. So people, they comment posts and stuff like that. Except that the moderator has potentially to review comments, because sometimes people, they leave inappropriate comments. And that's the thing. This process is manual. So you have the moderator of the group or the chat or whatever that need to review the comments and take off the inappropriate one. And here we have the ability to use machine learning to be able to detect automatically any comment that is inappropriate, to potentially flag it. So you don't need anymore a moderator to say, hey, this comment is inappropriate. You might add up or let the moderator select from the flagged ones, but at least you reduce his intervention, and you increase potentially the customer experience as well. You increase people experience on the platform. So that's our use case. This use case has been, I really had a dilemma in selecting the use case for this session, because I had another use case, but the other one was less sophisticated. This one has really something special, the ability to push model from a pipeline of retraining to a deployment framework, and have access to an endpoint. And this can be potentially run on schedule. And then you have automatically an update of your model, which is very, very interesting. Not just cool, it's very interesting, because that's something, as someone working in MLOps practice, that you will potentially have to develop. Something I just remembered, when I was talking about the skills, keep in mind that if you want to build up skills in MLOps, you will not be the best in machine learning, in DevOps, in programming. Usually you need a good knowledge in all of them. You need to understand the DevOps side of it. But me, for my case, for example, I have a very good understanding because I have been a data scientist for a certain amount of time. So I have a good understanding of the machine learning portion. But I'm not the best in DevOps. And I did scripting. I created templates, framework for customers. But again, I'm not the best neither in DevOps or in scripting and programming. But still, I can add up value to a machine learning operation team with my skills. And that's something as well at companies they don't yet see, is when they start looking for someone with experience in MLOps, they start looking for someone that can cover everything. So in the interview, they'll start asking you, hey, give me this and that regarding DevOps, tell me about machine learning. I mean, I've never met someone in MLOps that has, at the same time, an amazing knowledge in DevOps, and at the same time, an amazing knowledge in machine learning, and is an awesome programmer. So just keep that in mind as well for you later on. So here is as well something great, is that we do have a notebook here. So what we'll do is how we can go from a notebook developed by our data scientists to production. We will be skipping the portion of CI, so continuous integration, and components creation, but we will talk about it briefly, and we will identify our different components that will be reused later on in our pipeline. Any questions so far, guys, before we dig in a bit in the architecture of our solution? Okay, so please don't hesitate again to interrupt me if you have a question or you want me to specify something or something you might want to discuss. So our architecture, obviously we run on Kubernetes. Let's say we created potentially components, and now we want to deploy all this for continuous, potentially for delivery at least, not maybe continuous, but delivery. We do have data coming, updated data potentially coming either from a Reddit feed, so live feed from customer that sits in potentially a queue, or we might have as well an S3 storage where basically all removed comments, so comments that have been flagged in Reddit as inappropriate, with addition to other data that were considered appropriate in an S3. And this will be our data for retraining, because keep in mind that our data scientists, they developed the first model. But the thing is, we want our models to be up to date, to be updated on a regular basis. Potentially, knowing, if you know how Reddit works, we might want a model per subreddit, potentially, or we want a model per category of subreddit. That can be as well a potential option as well. And all this has to be decided by you as an MLOps practitioner. So in our pipeline, we will have the data extraction component. This one will take care of extracting the data from an updated S3 bucket, or like I said, from a queue that contains live up-to-date feed. After that, we will do data processing, obviously, because that's the thing with machine learning is whatever steps before building up the model data scientists are doing, these steps will have to be potentially replicated in production. Then we build up the classifier. So we build up the new model, and this model is updated potentially. I mean, that's not the same model as the one built by data scientists on the notebook, but it's a model that is up to date. Here, it's really open for all, I would say. You can have the ability to retrain the same model. You can have the ability to test 2, 3, 4 models and take the one with the best performance. Obviously, we will have as well a component called trigger deployment. It's not because you retrain the model that's necessary what you have retrained is good. You need to evaluate the model to be able to know if the model you have in the pipeline is proper for production, if it has the right level of performance to be pushed in production, to avoid putting in production or in deployment like garbage. So that's definitely our automated pipeline that will run on schedule. So we can run it every day, we can run it every week, we can run it every month, etc. Now you'll ask me, yeah, Mohamed, but how do we know when to run or rerun our pipeline? Well, that's a good question. And the answer is it depends. It depends on what? It depends on the dynamic of the data. If we do update the model, it's because we do believe that after a certain amount of time, our model might suffer degradation because there is a change, a drift in the dynamic or the distribution of our data. And this analysis has to be performed to decide high level if when do we need to trigger. Some companies, they don't do it. What I see often is they don't do this analysis and they decide just a standard. They say, by convention, we do believe that our model should be updated once a week or once every 3 months. I mean, I don't like the story of creating a convention because, again, it depends, and all what it requires is doing an analysis of the production data and see how the dynamic of the data changes, how the pattern of the data changes in production potentially. Now, after we have our pipeline trained, obviously the model will be saved in model registry. Here, I decided to go with the persistent volume. So you could have created a model registry in S3, in a whatever storage solution that you want, using commercial solution that do a model registry. Again, component is just a component. There is no really good or bad answer for what you select in your architecture in terms of technology support. Usually it's use case related. Here, my use case doesn't really require more than just a persistent volume inside my Kubernetes. Then, and that's the thing, when I go to production, when I go to deployment, I take back some of the components, reusable components, or actually an adapted version of components to have it in my deployment environment. So here, the same component data preprocessing is reused for the inference, is reused inside potentially my microservice or as a microservice itself. Why? Because you need it. Even if you build up a model that will do inference, you still need the steps before building up before predicting or training the model, because those steps are unnecessary for inference. And that will become our machine learning engine. Obviously, the trigger will take the model from model registry that was pushed from the pipeline and will use it and wrap it up in a microservice for inference. Same thing here for data preprocessing, except that here data preprocessing is not dynamic. The data preprocessing we do here is the same each time. So we don't need to save it in the model registry each time because it's the same. So all what we have to do is rebuild it in production with the same potential image, and it will be a part or a component of our deployment strategy. Then after all this is done, you will have the ability to do the integration with whatever application you have. Here we could integrate this with Reddit to stay in the use case. We could integrate it with Reddit potentially, which will help moderator to remove or select potential content. Any question about this? And keep in mind that we don't change endpoint here. So when we create our microservice, the endpoint will stay the same. We will have some sort of rollout that will update the images using what we have in model registry and have the last version of our model pushed in deployment.
So during the building classifier, do you need hyperparameter tuning?
You could definitely have hyperparameter tuning here. Usually something I see is as another option is after data preprocessing, people, they have model evaluation. Then you have the first, so they compare multiple models, I'm sorry. So you have 3-4 models compare. Then they select top first or top 2. Then they will basically fine tune those models. So doing hyperparameter finding, optimization. And after that, they push it. They use the trigger deployment, and then they push the model or the models or the assemble of those models. So yeah, and keep in mind that all this is flexible. I mean, you build whatever is suitable for your use case. If you need specific thing to do, you might add it up as a component. We do have another question. When retraining of the model triggers, can we assign the process to a different trigger for resources purposes? That's an interesting question. I would say yes, but keep in mind that there is always communication that you need to take care of, and you need to have the proper permission for playing between clusters, because here you can potentially have your model registry somewhere else. And your pipeline will send this model registry, your model to the model registry that is outside of the cluster. Cluster is not limiting you, really. The only thing you have to take care of is communication. I know that really one of the thing that can piss me off with Kubeflow is all the permissions with the namespace. The namespace has like roles in it, and you need to make sure that when you want to potentially modify the namespace or do something outside the namespace, you need to do proper edition. And that's what I did here. I edited the cluster role file, and I'll show you how potentially I did it. Jalpa, yes, you do have a question?
Yeah. I'm not sure if my I just had a problem understanding what's the difference between a trigger deployment and inference model.
Trigger the deployment is just what will basically send potentially the model and trigger the whatever microservices or have rollout to the production. Because if you don't do so, how would you update your model here potentially? This is performed by the triggering here. So consider the triggering as a way to send or update the image, and then update and then take the model from the model registry to send it to the inference model. The inference model just does the prediction, just the scoring, score, with a specific model defined by an image. And the trigger deployment will update potentially this image or do whatever modification on the microservice, which will change potentially the model. But the role of the inference is really focused only on scoring.
Okay. Thank you. Yeah, I do understand it now. Yeah, thank you.
You're welcome. Awesome. So I think I'm good for PowerPoint for today. Now we can move on to the hands-on workshop. And please, I'm sending you right now the workshop, the hands-on one. Have a look at, will you share the slide for us? Yes, I'll share another version of the slide. But if you want, I don't have your emails, guys. So please either send me your email on the chat if you want the presentation. I can as well send you mine if you want to communicate with me or send me your question later. I just sent, guys, the link. It's a Google Doc link for the workshop. So this is the tutorial you will be following, basically. Contains all the code you need, everything. And at the same time, like I usually say in this type of long length workshop, if you don't have time during or whatever happens, you can leave it there and you have access to the documentation. You can potentially finish it later on. Let me know if you all have access to the workshop document I just sent on the chat. Awesome. Okay. Unfortunately, we will start with the annoying part. And the annoying part is you setting up your AWS account. So start with this. It takes a couple of minutes to set up. Please, if whenever you're done with this step, please send a message on the group saying that you have done that and that it's all set up, so we can move on to the next session. So just go on the console of AWS, then click sign in. After that, create a new account, and then enter all the information and follow the steps. If you already have a personal account, log in the personal account, and please send a message on the chat saying that you are logged in and ready for the next steps. Yeah, we'll give everybody maybe 4 or 5 minutes to create the account, and then we can move on to the next step. Awesome. We already have 4 people that have completed and/or already have access to AWS. That's great. By the way, you already, if it's a new account, you already have free tier, which is supposed to be enough for the workshop. Because what is costly in this type of thing is the EC2 instances, because that's what Kubernetes run on. But it's not supposed to cost that much to go over the free tier. If it's the case, all what you need to do is enter your credit card. Okay, 6 persons are ready, half of the room. Meanwhile, I can talk a bit about my experience in MLOps. Really, what can be a struggle sometimes. I don't come from a DevOps background, and sometimes companies, they start asking me for very technical DevOps things to do, or they ask me for day-to-day DevOps. I usually tell them that we need to hire a DevOps person in the team. I mean, you can't ask someone to be at the same time the lead for the DevOps portion of it, the machine learning overview of it, and the scripting and everything. So I usually advise company to look for people with proficiency in DevOps for that are really focused DevOps. But sometimes you get that's why you get different profiles. Sometimes people, it's the opposite of me. They get in the field and they are from a pure DevOps background, so they don't struggle with the DevOps portion. But when we start talking with them about machine learning, you start seeing that they don't have that much knowledge or in-depth in the field. So it depends. Really, the point of view might vary depending on what's your background and where you come from. By the way, the same exercise, the same workshop can be run on whatever cloud you want. You can do it on Azure, you can do it on IBM Cloud, you can do it on whatever cloud you want. Actually, even on-premise, potentially, you can have such a workshop. That's not much of an issue. I'll give maybe an additional 3 minutes, and we can then move on to the next session. Meanwhile, guys, if you are already ready, take the time either to read or you can even start if you want. I'll catch up later. All right, so if you didn't, if you're still creating an account, that's fine. Just relax and you're gonna catch up for the rest. So the first thing is make sure we're working on the same region. I'd rather select stay in US. I usually play in US West 1. Had issues last week with US East 2 due to availability zone. So basically, it's probably very popular one. So Amazon end up with no resource available for the instances I require. All right, so first thing, we'll go here and look for Kubernetes, which is Elastic Kubernetes Service. And every cloud provider, or the majority of the cloud provider, they do have such a service, which is a fully managed Kubernetes, like it says here. So this basically, I would translate it in Kubernetes with no headache. So you don't install, you don't really maintain by yourself with commands. All what you do is basically start the instance. You have access to auto scaling and things like that, which is awesome, to be honest with you. That's why I love using the cloud for Kubernetes. Next step would be to enter your cluster name and click next. Let's call it MLOps Word. Then click next step. Here, you need to create a cluster service role. I'll put my, I should show you my screen and leave the instruction here. There you go. Awesome. So the first thing to do is to create a role for the cluster. Basically, the role is every permission that you want to grant to your identity instance, whatever it is. This is critical because that's a good thing with such, working in this type of enterprise cloud, is everything is siloed, and that's a good thing because you don't want a free for all. You really want to make sure that everything is communicating properly and under the right permission. To have access to resource, to do whatever changes on data, to have access read only, etc. So many roles available depending on what you want to do. So then you'll have to click create a role. Then you go down and you look for EKS. Then you select EKS cluster here. Then you click next. So that's the EKS cluster policy. You have access to a description here, which actually says that your cluster is granted access to a couple of resources like instances, etc., which I suppose will help you for communicating with the nodes later. Then you click next. Next, then you give it a name it whatever the way you want. Then you just click create the role. After that, you come back to this tab where you were creating your cluster. You click a little refresh, and then you select the role you just created with the proper name. I'll use this one. Then you click next. The rest, keep it by default. Some are, if you decide to have a proper VPC for your resources, you can use it. Whatever you want, you can potentially change the modification depending on your case. Then next. After that, we basically click create. Takes a couple of minutes, sometimes less, sometimes more, to start it. Just refresh once every minute or two. Something, guys, is we don't really have a timeline or a duration for this workshop. Usually, it really depends on the amount. I can run exactly this workshop by myself in an hour. But sometimes with the questions, you want to read the materials and stuff like that. This might last 3 hours or 4 hours, depending really on the path and the pace and your questions, basically. So I'm available at least until 2:30. So whatever questions you have, we can cover this and have discussions later if you finish early. My experience with this type of open source tools is actually good. The only thing that I don't like is a lot of documentation use cases they share online and available are sometimes not up to date. So they are related to an older version of the tool. They don't work properly. So really sometimes takes time just to figure out how to properly set up that specific case, for example. Something as well that is headache is the management of versioning. The versioning between Kubernetes, because sometimes some tools, they don't work due to the way configuration files are, or the tool itself are not available on certain version of Kubernetes, or you have compatibility problems. And this as well can be just headache to figure out what to run with what. So our use case, I can talk about this briefly, is actually an adaptation of this code. It's from Kubeflow, it's from Seldon, except that this one isn't up to date. And there are a couple of bugs that I corrected as well, and readapt it in a way that I think it's a little bit more, let's say, following the best practice and more suitable. But I do believe that's a great use case to work on, because it's what I don't like about things available on MLOps online is a lot of this, what you see is just the basic 101. I mean, they show you how to deploy a microservice, but then, MLOps is not just deploying a microservice. So many like sophisticated things that you'll have to do later on that might not be explained properly, or just having a examples or template for that. I know that creating clusters and the DevOps layer things and stuff like that, and it's a bit annoying, takes time. I know it's not cool to show in a workshop, but you have to do it in a certain way. I unfortunately I can't ask you prior to this to do it. Discussed with David about what we can do and not. So I rather do it in the session and take a little bit more time. But that's usually the feedback people they give, is that the aspect is a bit annoying, but we have to do it in a way or another. Any questions so far? Something not clear, or something you want to share your thoughts about it? There you go. Now it is active. We created the cluster, but technically it's an empty cluster. I can call it this way. There is no node in it. So we need to go on compute and then click add node group. Name it the way you want. Let's call it MLOps 101. Now you need to create node IAM role. The same approach than the last one. We go in the roles. Then please follow the link. The link explains it very well. But short story, you just click create. Then you select EC2. Next. After that, you add up 3 roles. EKS worker node policy. Then you add up Amazon container, EC2 container, registry read only. And then the last one. After that, you click next. No need for tags. You name it and you click create. When you go back, you just refresh and you're supposed to have your role available here. Let's take this one. Next. We'll keep it to the T3 medium. But then we will have a minimum size of 6 and a maximum of 8. Then we click next. And this is interesting because if you're wondering why max, basically this is based on the scale out potentially you can have based on the resource usage. Then you click next. You need an SSH key pair, which will grant us the ability to establish a secure client-server connection. You'll have to click on EC2 console and create a key pair. After that, you just select your key pair and then click next. Click create. And then let's wait. You seem to be guys very like a silent group. Usually I do have a lot of questions like popping up here and there. People anyway, but usually it's a good sign. It means that you're running your workshop and you don't want to be bothered. So that's very fine. You can check, I think you can check this on my billing dashboard. But anyway, I run the exercise. Don't look at this. This is something else. That's not the cost of the workshop, guys. don't get worried for that. Technically, you can. Yeah, there you go. You can see the free tier usage here. So it shows you what do you have in free tier, but technically if there is a cost, it shouldn't be higher than $3 or $4 max. If it's higher, please send a bill to David. It's not on me, right? Okay, it's supposed to be. Yes, it's active. All right, so now we have an active cluster, but we're not done yet with the pre-configuration and installation. The next step is important as well. We will start Cloud9. Cloud9 is an integrated development environment. So you can write code on it, you can execute command potentially, and it's a browser-based. Why I decided to go with this, it's basically you could have been doing exactly the same thing on your laptop, but the thing is I don't know the configuration of your laptop. You might work on Mac, you might work on Linux, you might work on Windows, and I've done that experience asking people to run things from their computer, and it was a complete mess. So I rather all of you have the same environment. So at least we will be consistent during the workshop. But keep in mind that you can run this from wherever, potentially from wherever you want. So let's create Cloud9. Oh, I already have one. Let's delete it. Console. No, it says delete. So, and then create a new environment. let's name it MLOps. Next. Keep everything default except here, go in other instance type and select T3 medium. Very important here, T3 medium. Keep Amazon Linux too. Just I kept by default, but you can run as well Ubuntu server. And there are slight, like some difference in the commands and stuff like that. So that's another story, but let's keep it like this because I created the workshop this way. Now click next. It's a T3. Create. You are stuck in SSH key. That's interesting. Let me log into my account. Where was it? It was in, yes, create notes. Yeah. If we go back to AKS, compute. Here, when you create or add a group, here? Yes, let's just type everything. There you go, SSH keeper. Here you need to click on EC2 console. I don't know if that's what you did. And then you need to create a pair key. Give it a name. I need to delete all this, but that's fine. It downloads a PPK file. But then if you go back, you refresh here. It's supposed to be showing here. You're supposed to have it here, technically. Just like by clicking a refresher and creating the keys here. Awesome, you got it. That's great. Now what I wanted to do was, okay, I created Cloud9. Now we have storage issue. The thing is by default, and I looked for it, didn't find a way without this. Cloud9 comes by default with 10 GB of storage, which is not enough for our workshop. So let's resize it to 35 GB just by going on Cloud9. Click on your instance. Then storage tab.
Open IDE.
There you go. EC2. I was looking for this. Sorry. There you go. Now, when you are on EC2, this is where you need to click to modify the storage. Click on EC2 instance right here. Then when you are in EC2, you'll have to potentially modify the storage. Storage tab. There you go, storage. Then when you are on storage, click on the first volume ID here. So I was in EC2, in the EC2 instance of our Cloud9. I clicked on the instance and now I'm under storage tab. Now in storage, go look for volume, 10 gigabyte. We need to modify this. Then you go under action and you click modify. Now you enter 35. You click modify. Yes. Close. Let's give it a second. It's supposed to update. Now it's 35. Let's close this. Let's go back to Cloud9 IDE. Now we'll enter at once like a bunch of codes that will just basically attach this this volume that we have, because right now it's somewhere, but you technically you're not having access to that specific space. So by running this, it's supposed to have this volume available. Now let's enter a very simple command, df, and look for volume. And here you can see that we have 35 gigabyte, which is good. So we have enough room now to have fun and play with Kubernetes and Kubeflow. Now, the following is just executing a bunch of commands in Cloud9, obviously. But we need to first install kubectl, which is the command that will allow us to interact with Kubernetes cluster. I think kubectl is probably the most used command in one of the most used command in Kubernetes. There you go. Now it's available. Now we will install AWS IAM Authenticator. Again, you can run one by one, or you can run everything at once, up to you. So you are lost. Okay, we have someone lost. Where are you lost?
Actually, I had an issue when I tried to create the Cloud9 environment. I have like an error there that I'm using a root user instead of IAM.
Okay, have you, when you created the Cloud9 instance, is everything, you kept everything by default and changed to T3 medium, right?
Yes, yes.
Can you share the error you're having? Or maybe you can share your screen, actually. I'll allow you to share your screen. You can share your screen now.
Okay. How do I share my screen here? Is there an option?
Yes, it's the green button that you have.
Got it. Yeah. Okay. Yeah, that's my error here.
Wait, I can't see your screen because I'm allowing multiple sharing. Écran partagé. Now you have the right to share. Une seule personne peut partager. Oui. Okay, you can share your screen now. Awesome.
Okay, can you see my screen?
Yeah.
Yeah, that's what I got.
Can you click on the instance on MLOps environment? Yeah. Is this your personal account?
Yes, it's my personal account. Yeah.
Well, type cloud formation. No, formation.
Oh, okay, got this.
Yeah, delete this one. Delete the stack.
Okay.
Yeah, that's good. Now go back to Cloud9, type Cloud9.
Okay.
Just type Cloud9 in the search bar.
Okay, here.
Now delete this one. Yeah, it's already selected. Delete. Okay, create a new environment. Name it, give it a new name. Yeah, there you go. Next step. Other type instance. C3 medium. There we go. Everything by default. Next step. Next step. Yeah, you're good.
Okay, that's good.
Now you can stop sharing your screen and keep continuing the workshop.
Okay, thanks. Thanks a lot.
You're welcome. Awesome. So now, you see, I lost the track. There you go. The AWS IAM Authenticator on Cloud9. We need that because we want actually Amazon EKS to use the IAM to provide authentication to the Kubernetes cluster. Awesome. Now we will use as well EKS CTN, which is as well used for communication with EKS cluster. So this command is specific to EKS, not just to Kubernetes in general, compared to kubectl. Then we will install kfctl, another control command that will be used for communicating and interacting with Kubeflow resources. So what we did, not much complicated, just installing 3 or 4 command, one for authentication that will be used for authentication purpose, 2 for cluster communication, so communication with the cluster, and 1 for the control of Kubernetes, of Kubeflow, my bad, the last one. Make it bigger. Okay, now a very simple step, but oh, we have a question. How long? Node creation, technically, no more than 5 minutes. But sometimes, you know, clouds are not 100% reliable. It's not magic. So sometimes it might take longer depending on the region you are in, or I call it the traffic. So basically, how many instances are available right now, and that can play a role in cluster creation. But usually, based on what I did with this workshop, I would say 6 minutes max. Okay, now that we have finished the pre-configuration, we can move to connecting to our EKS or to our cluster, because our cluster is available. We do have an IDE to develop, but now we need to be able to communicate, like establish a communication with our cluster. This requires us to have access key. This is basically what will grant us the access to the EKS cluster. A very simple step for to perform. But before moving to this step, I'll give like maybe 2 minutes for everybody to catch up, and I can take the questions or any bug you may have, guys.
Question, how do we resize the EC2 instance, the size of the disk?
You mean resizing for Cloud9, right?
Yeah.
Okay. The steps are explained, but you have to go in Cloud9, look for your environment. Can you see my screen?
Yes, yes.
Okay. Then you go under EC2 instance. You click on the instance, then you go down, you click on storage, and you click on the volume.
Okay.
And here, when you are in the volume, click modify volume in action, and then change 10. You have 10 here, you'll change it to 35. And when this is done, enter the command in the step 6 in Cloud9, so you can make this volume available.
We really need a EKSCTL command here.
EKSCTL?
Yeah.
Well, not directly. It will be used by Kubeflow after. And it will be used in shell script. So you don't see it necessarily, you don't use it front, but you can test. You cannot install it, and you'll see at, I think, the 4th session, you'll have an error issue saying that EKS CTL is not installed. But technically, you can redo the workshop and do modification and use directly kubectl. All right. Awesome. So now we will connect to our EKS cluster. Let's go under your name here. Let's go under my security credential. Yep. And then let's go under access key. Now you need to create a new access key. I already have 2, which is the maximum, but click create access key and follow the step for that. This will download a CSV file. This CSV is very important. This has to be stored somewhere safe because that's what you will be using. And this is the CSV file you get. You don't have this, by the way. You just have the access key and the secret, which we will potentially use. From the file, basically copy and update the export with the variable, and update the cluster name to the name of the cluster you created. So if you go back to EKS, here your cluster has a name. Use the cluster name, not the node name, based on the one you just created. And I don't know why I do have 2 clusters here. That's weird. No. Okay. I'll delete this one. Cluster, there you go. This is the right one. Yeah. It's named here MLOps words, so I'll connect to it. And enter my AWS access key and secret. Okay, awesome. You're supposed to get this answer back from AWS. Now let's connect to the cluster by entering, by changing here the cluster name, MLOps word, and by changing the region. The region is, technically we are in US, I am in US West 1. So, oops, let's enter US West 1. Awesome. We are good. Now you are connected. But just to double check, let's type kubeflow, kubectl get pods. And yeah, it's good because we get a response back. Obviously, there is no resources found in the namespace, but we are connected. After that, we could move to the step of initializing Kubeflow on AKS. But I'll give you again a couple of minutes. If there is any question, bug you have, like you're stuck somewhere, let me know. Yeah, Jalpa, were you able to create Cloud9? It's already done.
Yeah, I'm just finishing up that process.
Okay, because this is, I can't, unfortunately, and no one can control this. It's really from AWS side, again, availability zone and stuff like that. So in some cases, like you can create a resource and it's creating on the fly. And sometimes it can take like very, very long time to create that specific resource.
Yeah, I understand that. Yeah, so I guess maybe like you mentioned earlier, the traffic might have been an issue for the node creation. So
Yeah.
it took like a good 15 minutes for me. But yeah, I'm just gonna catch up on the Cloud9 configuration.
Which zone are you working on? Which region? Like that, which region?
It was US, but I couldn't change it to the California one, and because I started configuring in the meanwhile earlier, so mine was East to.
East 2, yeah.
Yeah.
I already had issues with East 2 and availability zone. It's really a popular region, so sometimes it reaches a certain maximum capacity, so you can't create resource, or it takes forever to create the resource.
Yeah, I couldn't change it later because I already proceeded with the next step. So I guess that's why I'm facing a bit of difficulty now.
That's fine.
Thank you.
You're welcome.
Got a question. Where can I check my cluster name?
Well, technically, it's under AKS. So just type AKS here. And in clusters, you'll have your cluster name here. Don't use the node name, use cluster name here. And yes, Jack, you're right. Some are not updated. So just modify the region to US West 2. That's my bad. I didn't modify that portion.
Should we use the US East or US West?
Your region, because that's the region you work on.
Okay. So this line just add one more line under region, right?
Yeah, well, it enable the pod IAM policy to true for that specific region. Okay. So technically, we'll do just modification on the configuration file. If you have some doubt, when you get the file, just open it on the left, go on the file, and then open it. And then look at the modifications that have been performed to make sure that it's the right ones, actually, because it's something custom, so it might have like mistakes in it. But technically, it's supposed to run whatever you do. I always make sure that it's fault tolerance workshops, so everybody, you know, can run it. Okay, so let's move to the initialize Kubeflow on AKS. Again, a configuration installation is time consuming, but it's again a mandatory step if you want to move further. So here I'll change potentially before entering the code, I'll change the cluster name to my cluster name. It's called MLOps word. Then we good. So the file that it gets here is basically the configuration file for our Kubeflow. We will open it if you want, so we can have a look at it. I can discuss a bit about that specific configuration file. Now we will run the shell script. We will, after that, and now get and download the configuration file. Now it's available here. We can open it. And this is a very classic configuration file for Kubeflow. Here you can add up resources. You can potentially take off some of them, depending on basically what are you looking for to create in terms of toolbox. You have access to things like Spark operator, Jupyter, web app, notebook, PyTorch, TensorFlow, Katib, which is used by pipeline. You have the pipeline itself, and other that are more related to the system of Kubeflow. You have Celdon as well, and make sure just this always check for the manifest per version, because here we're using the version 1.0.0, but sometimes the versions, when you change the version, the supported tools in it by Kubeflow might be different from one another. So I'll invite you to go on Kubeflow manifest and potentially have a look at the components that Kubeflow might offer. You always have the ability to add up later other components. This is not static, so you can potentially add up to Kubeflow other components depending on what you want to potentially add later on. Now we'll move on to we could change the region as well, so we'll just open it here. Let's see what it says. Yeah, it's US West 2. So the region is good here for me. We would like to add modification on slide. You see, my script isn't, you do have a mistake here, guys, by the way. Here, you have to take off the hashtag in the configuration file and then potentially save it. Use as well this command to make the session read configuration information from the file, from the config file. Okay, then we can potentially done. We can potentially deploy. We do have on Kubernetes. Let's see if it's working. Yes, it's supposed to be good. Okay, so it takes a minute or two usually. Okay. Anyone struggling or stuck somewhere? I'm hearing like a beep beep beep, so I wonder if someone has. Let's have a look first at our pods in the namespace Kubeflow. So everything seems to be up and running or container creating. Give it a couple of minutes for everything to basically become running status. This might take a little bit more time, but that's a necessary step. Any questions so far, guys?
Can you show me the kfctl YAML file again? After you run the set command. Yeah. The row, okay. So you change the 352 line to this.
Yes, it was like this basically, and actually I just like took off the hashtag because my my commands for editing the file are not like 100% reliable. They did a modification, but it was a partial modification to the file.
But I'm just curious. So for your the last set command, last SED command, you change the role to EKS-CTR workshop, EKS workshop, but I did not see you have a EKS-CTR workshop.
Well, technically you should hashtag this one and this one. So because this is basically not, because here when you change, when you apply the modification, it's changing as well on, if you take off the original file, it's not the name are not the same. This is basically because we have changed and entered earlier some environment variable. But you're right that I need to rework on this portion to make it more consistent, because some of them I just scrapped some code and I readapted to the workshop. So it's not technically, if you run this like this, you're supposed to have a bug, like an issue, like an error. It's not supposed to work.
Okay, so we should have this row, but the row's name is supposed to be the
yes, based on your based on your cluster name, exactly.
And the no group row, right?
Yes.
Okay, okay. So I need to figure out my no group row. Okay.
Awesome. So everything is up and running. Now our last step, we will be exposing Kubeflow dashboard through our ingress, which is, by the way, Kubeflow is using issue ingress. You can potentially, I've seen other workshops where you can change that that ingress to another ingress, but that's the default ingress for Kubeflow. this will just do a patch. So we change to basically expose our dashboard. We need a load balancing on the ingress gateway. And technically, this will give us an IP address that we can potentially have access to it. Obviously, it's not going to work because it needs a couple of minutes to become available. It's an ingress, basically. It's an ingress. So I can send you, if you're not familiar with ingress, I can send you documentation about it. But that's super important for the service networking and your ability after to set up like load balancing through this ingress. English version. Yeah, there you go. That's the documentation about ingress. I call them like the house doors. So technically that's what it is. It's the house door. With this, you can get in, get out from that ingress specifically. Okay, so technically you're supposed to have access to this dashboard. Welcome to Kubeflow. Let's maybe before jumping to the next section, let's give you guys maybe a couple of minutes to catch up, and I can take like any question or if you are stuck, let me know.
Quick question.
Yeah.
I'm actually at trying to, when you open the IP address in your browser, click next and enter a workspace name. So how do I open the IP address? I think I missed something here.
You are at the last step. So get external IP and enter it in. Well, when you enter the command describe kubectl describe, it's supposed to give you this load balancer ingress. This is basically the address exactly that you will be using, and then you can paste it on your browser. Wait a couple of minutes because it will refresh by itself, and then you'll have access to Kubeflow.
Okay, gotcha.
From one cloud provider, it's very weird. They do use different methods. Other clouds, they provide you like a direct IP address, but Amazon work differently, but that's fine. So after this, technically, we're done installing stuff. Now we will more move on to the practical side of it to really be able to create pipelines. But if you are planning to specialize in MLOps, like be a part of a practice in machine learning operation, do expect like requirements where you need to set up environments. They ask for that. I mean, you will have support technically of DevOps and IT for a bunch of stuff, but you will be owning definitely the environments. Awesome. So welcome to Kubeflow, and let's start the setup. Create a namespace. Name it the way you want. Now you are in the interface of Kubeflow. Little exploration is here. We have access to pipelines. So this is the main interface for building up retraining strategies, ETL, whatever you want to do, machine learning training. Then you have the notebook server, and this is cool because here you can potentially run your development environment in notebooks for data scientists. So data scientists could use this as their development environment where they create notebooks here, and potentially they compile and send pipelines or create pipelines. Then you have Katib. Katib will help you for experimentation. You can do hyperparameter tuning, what they call as well neural architecture search. Interesting features. Let's say it's a good to have. Not really like a key feature here, but it's a good to have. Then you have the artifact store. So here potentially you could use this as a model registry somehow, or at least have access to any artifact created by pipelines. So very user-friendly interface, like nothing to worry about. Have access to activities. Yeah. I mean, you have the documentation of this right here. So potentially you could dig in and understand like what Kubeflow does. They do have use cases here that you can have a look at. You have access to every components here. So potentially look for the different components. The only thing I'll warn you about is versioning. We work with this version because I do prefer, and I consider this version as the most stable. But you have access to all other versions. So make sure that you are reading the material for the right version. So now we will go on notebook server. Let's first okay, because I'm again interesting. Let's see if I can create a resource. Okay. Let's call it simple test 101. Here you have the ability to use images, like if you want to enable GPUs. By the way, this is very common with Kubeflow. And inside the notebook, you could potentially do it as well. Let's use this image. You can use as well custom image, by the way. So if your image is in Docker Hub or somewhere else, you can potentially have access to that image. Allow resources. So allocate resources here, be able to have CPU, memory, depending on what you want to run potentially. And obviously we do have access to, we can as well change the storage. And this is specific for that notebook space. You can add our volumes potentially if your data set is available, I don't know, in S3 or somewhere else. This is configuration, but seems like it's for setting like environment variables. And then obviously you can have this GPU allocation, potentially select the vendor and then run it. Let's see if it's working for me, because it seems that it's having an error with between my user profile and the namespace. Someone asked a question about you can't add a namespace value. Okay, that's interesting. You want to share your screen very quickly?
Yeah, sure.
Go ahead.
Yeah. Can you see my screen?
Yeah.
I can't.
Top left, select namespace. On the top left.
On the top left. Oh, here. Okay.
Yeah.
Oh, okay. Oh, I missed that. Sorry.
No, that's fine. Keep going.
Thanks.
Okay. So even if with the bug of user management here, knowing that I'm anonymous and namespace has been defined as another name than anonymous, it seems to be working. Let's see if I can connect. Okay, it's fine. I can connect definitely, but they do have, I invite you to read the documentation about user management in Kubeflow, because they do have the ability to manage users by defining some specific configuration that will allow you to create users and user passwords. So what I'm trying to say is this is a tool where you have the ability to work as a team potentially. Now, let's go right here in new, right here, and click terminal. It will open up a terminal in the notebook in the server, Jupyter server. Now we could clone my GitHub, my Git, actually. Now we do have access to this folder. Go under ML training, Reddit. What I want to do now is I want us to explore the type of work a data scientist will potentially do. Before the continuous integration, let's first have a look at the type of work delivered by data scientists in general. So I'll take off this. Go. So and this will give you a good understanding of potentially the case and the type of data we do have. So here really what we do have is we do have, let's take this one, this is more relevant. We do have the body, so the comment left. We do have a potential score that I didn't understand much, but it seems that it's potentially related to the popularity of the post. But the interesting thing that we have is the removed. Is the post removed or not? And you have a true false associated with that. Obviously, you have access to create a date, and the date it was retrieved with a couple of IDs here that we do have as well. So this is the data we have. So the idea is each time we get a comment on a post, to know using machine learning if this should be removed because the content is inappropriate, or we should keep it because it's definitely a comment that should be on that post. So here, the first file is really an EDA file. So it's an exploratory data analysis file where we just explore potentially the data. So, and that's something that I wanted to discuss as well, is from an MLOps perspective, it's interesting to understand maybe less the EDA, more the data preprocessing, but just having a good idea of the type of use case, and you really understanding the use case will help you manage what comes after the experimentation. Because I realized that the more you master like the use case, the data, the type of work performed by the data scientist, the more you can foresee potentially problems in the future. Is there anyone with the data science background in the crowd, guys? Someone who's a data scientist potentially? Awesome. We do have a data scientist. Well, I'm quite sure you feel very comfortable with this. There are many ways of solving this type of problems, but a typical discussion we would have with data scientists between the MLOps practice and the data scientist is the approach. Because you could have the approach of really doing feature extraction. So really extracting feature from the raw text, so, or the clean text, the one without potentially stop words or whatever, and be able to extract like features like, is there any link, like HTTP link in the comment? If is there any, like the count of the stop words, the length, etc., and work on a feature extraction base. But then usually the kind of thing that I would say for such a case is in production, aren't we limited if we do that kind of approach? Because the problem with extracting feature from natural language or from text is that later on it's hard to make it evolve because it requires manual, a person has to define what are those features potentially. And this can potentially limit the production capabilities and later on any improvement that we can go get from retraining. What people would tell me here is, oh, Mohamed, let's use potentially a deep learning approach, which can be interesting because when you want to translate it in production, it can potentially not limit you like the traditional approach where you might want to extract features. But that's I'm just like thinking about the potential discussions that you could have around this use case between the production and the experimentation. Here, the approach used is actually very simple, using tokenizing or tokenization with TF-IDF for really be able to extract like words or subwords and then be able to evaluate how relevant a word is potentially in a document, which is very basic. And it translates quite well in production. So, and that's a good thing to do each time. When you work from data science perspective, try to translate or project the work performed in production. Is it suitable in production? Is it suitable to, or is it, do you have the ability to automate it later on? Because if it's not the case, if, like I said, if you work with feature extraction and building up features from raw text, then you know that it needs manual update, because a data scientist needs to review those features, review the data and say, hey, we might need to add up this and this feature. This cannot be automated. And this will help you evaluate which approach. So sometimes you'll do sacrifices. Like maybe the data scientist can come back to us and say, hey, the feature extraction is the one showing the best result. But we know that we cannot make it dynamic. We cannot evolve these features with a certain automation level. Then we might decide to go with a simpler approach just because we can potentially automate it. So this is the kind of trade-off that you might be doing as well.
Does this support PySpark in this Kubeflow or Jupyter image?
Which image are you talking about?
This Jupyter. This Jupyter.
This Jupyter notebook. That's a good question. Actually, it's supposed to, because we installed. I think we did install PySpark. If it's available or you can use it, that's a good question. I need to check for that. But technically, it's supposed to be, because, or if it's not the case, knowing that here, because that's the image, it's TensorFlow 2.1. So we need to check if what this image contains. But technically, if you go on Docker Hub, you could grab like notebook image that is or contains PySpark potentially. Does it make sense?
Yes.
Okay. And that's a flexibility you do have, because if you do remember here, we have the ability to upload custom images. So it can be whatever actually is available on potentially a notebook,
yeah,
and already built on an image, or your own image if you have created one.
So does your sample code use TensorFlow?
This is just a default image. It's a default image provided. But I don't use TensorFlow technically in this code. Okay. I use, I think, scikit-learn. Yeah, scikit-learn. Okay. Scikit-learn and Keras.
Oh, Keras uses TensorFlow. Keras is on top of TensorFlow.
Well, but yes, we do use TensorFlow as well for this image. You're absolutely right. We use Keras that runs on top of TensorFlow. Yes.
So should I run this data preprocessing first, or run this?
Well, you don't have to run the files, by the way. You can. The idea of the file is just doing a review. If you want to run them, you can have a better look at the case. But the output are already here, and we will not use this as a template for later on. We'll use another approach.
Okay.
But you're absolutely right. We definitely use Keras that is running on TensorFlow. Can you run the cell? Doesn't have packages. If the packages, which packages are not installed?
So actually, when I run the cell, it says that sklearn is not installed here.
You have to run pipe install.
Okay, I thought that these packages were in the environment.
Yeah, let me double check. So this is the command you're supposed to run. Run it and let me know. Open, like create a new cell and try to run this command. Yes, because here we compare, we will compare multiple approach, and that's something I forgot. Here we will run a couple of models using scikit-learn, which are we have a logistic regression here as a start. We do have a couple of models here. And we will try deep learning. There you go. Then we have a deep learning model with actually a simple one with an embedding layer, one small dense layer, and one last layer to install packages. Okay, use this then. Use, because that's another bug related to the notebook. This type of instances is that it doesn't allow it doesn't allow you as a user sometimes, because it doesn't consider that you have the right privilege to install packages. If it still doesn't work, I could send you the commands that you need to follow to allow this type of permission. Okay, so yeah, I mean, this is a very classic data science machine learning project. Another interesting thing that you need to translate later is evaluation metric, not just models, but evaluation metric. So you will have to understand which evaluation metric are used by data scientists, and is this metric reusable in your pipeline? Because you want to create, the data scientists will help you create components, and they're supposed to know and be coached for creating artifacts and things like that, and help you really outcome a component that will be used to build your pipelines, depending on the type of practice you work on. But technically here, for example, we have a lot of visual like confusion metrics, visual metrics for evaluation, which is interesting. But for this case, we would potentially ask data scientists to work more on using things like precision, recall, F1 score, accuracy, because they are basically numbers. So we can potentially reuse them to automatically have model evaluation in a pipeline. I mean, think about it, it's just logic. If you use confusion matrix, how can you automate this inside the pipeline? Who's going to do the interpretation? I mean, that's something you need to think about it as well. Here, knowing that we output probabilities, they basically set a threshold of 0.5, which is a standard. But definitely, even the threshold can be, threshold definition could be automated later on by finding the optimal balance between precision and recall to get the optimal threshold for probabilities. Awesome. So yeah, I mean, really supporting data scientists from moving, and this is as well an important step, is from how to move from a notebook to components. And I'm not going to give an answer now. I'm just going to show you the other side, like the outcome, the components and the pipeline. And we'll discuss, because this is not something I cover, but it's very important as well, this portion of the continuous integration, because you need tooling, you need coaching of data scientists, because they need to wrap up their code potentially. So it becomes proper for pipelines and production. Awesome. So yeah, I added a link to the original case, which is Science Popular comment remover. Have a look at it. It's a Kaggle competition. I mean, just a great use case with unstructured data like comments potentially. Now, okay, let's go back to our terminal. We will run our first pipeline. Now we will go to Cloud9. We will go back to environment. Then we will clone our Kubeflow. There you go, Kubeflow session 4. Then here you can click right and then open up. This is how a pipeline is built. The true configuration file that will be used is a YAML file, but we don't write up this. We basically draft a Python code that will be using an SDK called KFP. So it stands for Kubeflow pipeline. You need, if you want to work later on with Kubeflow, I definitely advise you to really master this this framework, because there are commands that are associated with this that will help you build up the components of your pipeline. Kubeflow supports mainly Python, so you will write your code and component of pipeline using Python. So here, this will define a potential component of my pipeline. And with the decorator, it will potentially create some new flow each time. If you want to really deep dive in it, I can send you a link to a great tutorial of this SDK. And have a look at it, really explore it, because this will help you later on be able to build up your own pipeline. At the end, we do one thing. We compile, so it will be converted to a configuration file. Another option here, instead of really doing the conversion, you can directly submit your pipeline from, for example, you can write down a notebook, and in the notebook you'll send to, and this can be outside, by the way, outside Kubeflow pipeline and outside the cluster of Kubernetes. So you can do it from your laptop notebook, or from, I don't know, your IDE in Python, and then send the pipeline, submit the pipeline to Kubeflow. That's something you can do as well. Now, if you run this, you will get this configuration file. Then you can potentially download it, because we want to use the interface to be able to upload this pipeline. So let's call it test 101, pipeline test 101. We will upload the file, choose, oops, create. There you go. Now you have your graph. You can overview here the different flows. This is a very basic example, just printing up a bunch of stuff. We will see the most exciting one. This one is just to warm you up a bit and make you more comfortable. Now, when you have your pipeline, you can create potentially a run and make it under experiments. And this is cool because you could split your runs into experiment. I like this feature. This will help you get like a more structured work inside the same potential pipeline. So let's use this. And obviously the awesome feature is the recurring, your ability to run and trigger your pipeline and have the ability to set up starting date and date, run every minute, months, hour, day, weeks, etc. Let's keep it a one-off and let's start our pipeline, our experiment or our run. Really, if you want to learn Kubeflow, the main thing you need to learn is the SDK, the KFP SDK, because that's how you'll build pipelines. I do believe that data scientists can create their own pipelines because it's still in Python. So technically, with the right training, you could have a data science team that submits and creates pipelines, obviously with the overview of someone from the MLOps practice, but that's definitely doable. I have seen scenarios like this. Awesome. So our run is good. Now, let's wait for this one. By the way, to better help you understand how Kubeflow pipeline will work, every component here will initialize a pod. So technically, everyone is a pod. If we go on technically kubectl, get pods and Kubeflow. There you go. Here, you have some of them that are, I call them temporary, but they were used for the pipeline. They were used for building up the pipeline. So it uses resources temporary, and every component will potentially start its own pod. Here you can go on logs and see outputs. This is very interesting. I do believe that this is the logs of the pods. So technically, if you do have an error in the processing, you'll see it in the logs. Then you have the volumes associated. You do have as well access to input-output artifact potentially. And yeah, input, output, and artifact. So yeah, that's a very quick overview of what you can potentially run and do with Kubeflow pipeline. Now, what we can do is dig in a more sophisticated use case that is more suitable or actually adapted to the things and stuff that you will do, because that's cool to run 101 like this one, but that's 101. I mean, how would you deploy your model? How would you create components for the different steps you do have?
Hey, Mohammed.
Yes.
when you run kubectl get part, I saw your from Kubeflow namespace.
Yeah.
But mine is, I saw you are using another namespace from your Kubeflow console. You were using MLOps 101, right? Use -n MLOps 101.
This one actually, and this is weird because I do agree with you that technically all your runs should end up in
this namespace.
Exactly.
For me, I'm using admin, so I can see this the pipeline part in the admin namespace instead of Kubeflow namespace.
Okay, so yours appear in this namespace here, not in the Kubeflow namespace.
Yes, my pipeline is in this namespace.
Have you created another experiment?
No, I just use default name
Default.
experiment.
Okay, that's interesting. But that's definitely the type of thing that you want to handle, because if you want to stay consistent technically, I would do it your way, and I would leave Kubeflow namespace for the the basic configuration, and use the MLOps 101 for potentially the deployment and the runs.
Right. That is my case.
Yeah, and that's a good one. Okay, so now we can move to the next and most exciting section of our workshop. But before we do so, I'll give you again a couple of minutes in case you need to catch up, so we can move on to the next session. And this is, by the way, I should have shared this, but this is if you want to submit to the client the pipeline or create a run from the pipeline. This is the function to it. But anyway, all this is detailed in the documentation potentially. That's the thing. Kubeflow is specialized for machine learning, and you work with Python mainly. There is no the SDK is not available in other languages, so it's really was created for data scientists, or for at least people in machine learning project. Airflow, you can do automation for any type of pipelines. I mean, you probably will use Airflow for all sorts of things. That's the main difference. I use both. I like the way of working with DAGs, even if sometimes I get lost in DAGs, to be honest. I find the learning curve of the SDK of Kubeflow easier than the one for Airflow, except that from what I heard, Airflow is potentially a little bit more robust. That's the only feedback that I got. But technically, if you already use Airflow, keep in mind that there is a learning curve for Kubeflow. One other good thing is Kubeflow here is more of an environment. You have at the same time ability to for data ETL, right? And you use Kubeflow for machine learning. Oh, well, that's awesome, man. Because if you are if you have Jack both of them, I mean, yeah, exactly. That's what I said. Kubeflow is dedicated for machine learning. So it's really built across that. And the cool thing is I moved a couple of people to Kubeflow, just data scientists, just because they do have the ability to run their own experimentation here and submit their own potential pipelines. So it's really for data science and machine learning. If you could do ETL on Kubeflow, definitely you can do ETL on Kubeflow, but I would say it's not the main purpose of it, but still, I mean, you can definitely do that for. But the fact that you use both in your team, that's cool, actually. And my feeling is, or my experience, the learning curve of Kubeflow is smoother and, let's say, better than the one of Airflow. But again, I mean, that's my personal opinion. Potentially other people might tell you the opposite. That's really depending on your background and the individual. That's what Jack is doing. Jack Jane just answered that, saying that in their team, they are using Airflow for ETL and Kubeflow for machine learning pipeline. Except that that's the thing, if your ETL will feed in somehow your machine learning pipelines, so you need something in between. I mean, a basic way of doing it is just like an S3 bucket that will be used to get machine learning data for machine learning pipeline. But definitely you can technically combine both. That's not a problem. Again, the architecture is really depending on the use case. But for me, if you go from scratch, that's the thing. If you want to implement both, your guys need to know both, or some of them need to know some, and the rest need to know. Jack is saying our ETL use Spark cluster on EMR, and Airflow, Kubeflow are on EKS. That's good. Airflow runs as well on EKS, so that's not supposed to be an issue for scalability, but I'm trying to think. Both of them scales pretty much, pretty much well. With a certain version of Kubeflow, I got some, let's say, latency from the user interface, but recently I changed the version and I don't have that issue anymore till now. Awesome. Anyone struggling before we move on to the next section?
I have a little bit question.
Yeah.
I'm reading your document for the next session. and I saw you are building image on Cloud9, and once you build the image, and you said
I don't push them, right?
Yeah, you don't push to
exactly,
ECR?
because I reused my own images, and I'll show it later. Just because this process needs you to have access to a like Docker registry, and this step would take probably another 45 minutes, and we don't have that time. So
Yeah.
I just showed how to build the image, but potentially you will need, and that's what I explain in the notes section, where I say that you need like a new registry to push your image. Then you'll have access. You can potentially mark and use those images. But you're right. You need to push the image. Does it make sense?
Yeah, but in your in this workshop, you don't push the image to ECR.
It's already done. It's already done.
Oh, it's already done. Okay, got it.
Yeah,
okay.
It's already. If you go, I'll show it during the next section. But if you go, you'll see that in the main Python file, I reuse my Docker Hub.
Docker Hub. Okay.
Exactly, images that I already built for you.
Okay.
I skipped this step just because it's a step that will require some people that maybe don't have like a registry to create it and then push potentially the image, which will consume another 45 minutes.
Understood.
But you're absolutely right. You need to create the image, then you need to push it and make sure that you identify those images in your different files, because we will be reusing them in multiple times, not just for the pipeline, but as well for cell done.
Yeah.
Awesome. So let's move to the next section. So create a machine learning pipeline with Kubeflow. Now go back to Cloud9. We'll clone the main Reddit ML pipeline file. Then we will install some required Python libraries. This is the file that is available here. Yeah, and it has some libraries that will be used by our pipeline, but as well the SDK for Kubeflow pipeline. Now install setup tool.
What is a Spacy?
It's a library used, I think, for raw text data. I can double check it.
And what is this EN Core Web SM?
It's it's a package used by Spacey or available by Spacey. Yeah, that's what I thought. It's for natural language processing. I can send you
Okay,
the link
okay.
to it. There
Okay.
you go. Awesome. So now we can build up our images. We can build up our images. We use S2I here. So source to image. It's basically another way or another standalone tool for creating and like for creating and building images. But you shouldn't worry much because I'm using this specifically because Seldon relies on this type, or the Seldon, let's say, state of the art relies on S2 for building up the images. And to be very honest with you, I never tried building up images for Seldon without S2I. So I'm really curious to know if I could potentially do it using Docker. Supposed to, but never tested. So now let's copy it. Awesome. Now we can take some time to explore files. Okay, here in train pipeline on my left, you do have the main Python file. On the top, we have the deploy pipeline. So this one contains Seldon configuration file, okay, and some persistent volume access, which we will probably not use in this section. Here you have the pipeline steps. So these are the components. For example, like I showed in my PowerPoint, we have multiple components. We have one for downloading the data. We have one for cleaning the text. We have another component for tokenizing. We have another one for TF IDF. And we do have another one for building up the machine learning model. If we take the one for the data downloader, so the one that will download the data, here you would have access to basically the component itself. And the interesting thing is you have two options here, and I'll show it to you. If you want to build up a pipeline, and I need to show you the main file for that, you have either the option to include your code inside your pipeline's components. So really inside each component, say, this is our functions, this is what we want to do, etc. Or you have the ability to create images. So your pipeline will rely on images. I prefer images because it's easier to update. And it's basically, it might sound like a little bit longer to build, but at the end of the day, for updates and the rollout, it's better. So you don't need each time to potentially, if you do modification on the image, to re-update or to re-upload the pipeline. You might just keep it as latest version and then be able to re-upload or reuse the layers version of the image that you have recreated potentially. So yes, every component comes with a requirement file, obviously because each one is using specific libraries. It has a Docker file as well, where it will copy all the content here to a specific folder, then make it a working directory, then install the required library. And that will be our image. Here you have this shell script is just basically a shell script that I reuse later to build the images. Instead of entering each time S2I, like S2I, whatever, create image or Docker build, I will here use a shell script that will run it potentially. But technically you could run this command and it will build up the image. So yeah, the most important tip, I don't want like give you too much of a lot of content at one shot. So the most important thing that you have to keep in mind is a good practice and a good way of using and the SDK of Kubeflow pipeline is by creating components that are built using images. And the way I like the way that it's performed in this workshop, because basically every image will basically provide later on the ability to run a Python like to run the Python code as a script. So it will run potentially this one, execute this one with specific argument, like you can see here, that will be added. So potentially you could, if you want to do modification, like one of the modification that is interesting here that you can potentially do is move from a training pipeline to a predict pipeline. And this is already, this ability is already added here. So it will give you the ability not to just retrain your pipeline, but as well be able to directly do predictions. So it's like an inference pipeline that will run predictions instead of using the microservice. You can use the pipeline for prediction, not just retraining. So it will take data on batch coming from a specific source, and then it will start doing prediction on it, and then potentially can send the prediction wherever you want. So this is interesting because you can create reusable pipeline for different purposes, really with the flexibility that is offered by the SDK, Kubeflow pipeline SDK. Anything else that can be of interest that I can share?
Yeah.
Yeah.
Did you say you can use S2I instead of this build image.shell script?
No, it's if you go on, for example, let's go on this one. This is the training the model. You click here, it's in the shell script. You are using S2I.
Oh.
Except that here we are using S2I because S2I will take the Seldon core base image. And because this is something I need as well to explain you, is the same. We reuse the same. So this is our, let's say this is our Python file. This is the Docker we have here. Or no, we don't have Dockers for the ones that are used by Seldon. We do have like a .txt. And the thing is, when this is converted to an image by S2I, this same image will feed two things. Let's say this is this is the component for doing TF IDF. This same image will be used by the pipeline. So let's call it KFP. And it is used as well by Seldon. And that's where it gets interesting, because one of the, there are two, some of them have two Python files, have the transformer and the pipeline step. The pipeline step is used by KFP, and the other Python file, which is transformer, is used by Seldon. To make it easy, instead of creating so many images, the same image is reused at the same time by KFP and by Seldon. Seldon knows what to look for because it looks for that S2E file, which is one of the files that is there. It's just you can't see it on on Cloud9, but it's there. There is this file that contains instruction for cell done. So he knows that he needs this file with potentially this txt file. And KFP will potentially take the other file as well. So this is basically the high level view of the way the engineering we did to build up images. This is just suitable because we wanted to reuse the same, instead of having many blocks, we could have been like building up one image for cell done, one image for KFP. Here we built one unique block that contains both, with instructions for both about what to use exactly. That's what you need to keep in mind. And we used S2E when it's something that we want to deploy as well on cell done.
Cell done do the inference. Right?
Exactly. Cell done, I'm sorry, I didn't talk about cell done, but cell done is basically a framework for creating microservices for machine learning. It's a super cool tool. You can do with it A/B testing, multi-arm bandit as well. It comes with installed with like a monitoring on Grafana to monitor the health of your API in terms of responsiveness.
What is this this part, this middle part?
This is the image.
You said with S2I you only build one single image.
Yes, one single image for each component. So it is a large block that will be reused by both cell done and KFP.
So S2I will use Docker to build image and push to the Docker registry, right? So S2I is
S2I allow you S2I allow you as well to push to modular registry.
But do I have to define which repository I have to push to with S2I?
With S2I, technically, I think it's the same. It's the same protocol than for you use Docker push. After building up an image, you use Docker push, and then you specify the image, because even S2E images are available under Docker image because it's still considered Docker image.
Okay.
A/B testing, what's the note there? A/B testing. A/B testing is basically when we put in production, something very common is that we don't push just one model. We might think, oh, look, Mohamed, we do have two models that have almost the similar performance, but we don't really know which one is better. So I'm like, okay, calm down, give it to me both. And I put both in production, except that I put them, we can say we put them in competition, again, once against another. So basically a certain amount of time one will be used and then the other one. And then the result of this, we can perform like A/B testing statistic to know which one is actually overperforming the other, to understand which one is the best. And this is very common. You get multiple models and you don't know which one is the best. Yes, you can do A/B testing through cell done framework. In here, you define this. How can I take off what you did? Because it's still showing on my screen. Okay, Jack, if my computer is broken, you owe me one, okay?
Oh, hold on. Let me one second.
No, that's fine.
I need to clear. Where is the clear?
Thank you.
Okay.
Actually, I didn't even know that you can write down on my side as well. That's actually super cool. Yes, it's here. If you go in the configuration file of cell done, you have the ability to here when you define what will be the microservices you want to create potentially with the specified volumes. You might want to add in the children the ability to specify that, hey, I want this model against this model in A/B testing. So it's just a configuration stuff inside the framework that allow you to do that. And I can send you documentation about this. Cell done A/B testing. I do believe that, yes, There we go.
But the Kubeflow does have KF serving.
KF serving, exactly. They do have KF serving as well.
So you are not using KF serving, you are using...
In this case, no. I do believe that Seldon is more sophisticated than KF serving. KF serving is good, but Seldon is more sophisticated. It has like great, and I've seen it in production Seldon with one of my customers. It's doing a great job.
But is that Seldon part of the Kubeflow, or you have to
Seldon? No, Seldon is a part of Kubeflow.
Okay.
I can show you.
Yeah, I saw it. Yeah.
Yeah, you can see it in the configuration file. Yeah. The configuration file, it's here. If you do open it, you'd see we do research, Seldon. Yeah, it's here. So it comes by default in the version 1.0.0. Awesome. So what is the next step on last right now? I installed S2I. We did exploration. Now the next step is to build up images. So the bunch of code that you see is just us building up images through a shell script for each component. And we do have 5 components. If you run our, oops. What did I do wrong? Okay. Oh, it's Docker. I'm not. I need to log into my Docker. My bad. So technically, I can't push images, but I need to register to log in my Docker account. And then I will have the ability to push images to Docker Hub. Yeah, there you go. Now it's supposed to be working. But like I said, if I go on my Docker Hub, yes, it's already here available, and I can see that some of you did the download of the image. That's interesting. So yeah, it's already available here, publicly available. So technically, all what you have to do after that is be able to basically specify the images in your Kubeflow components. So here again, I go get the proper image. And then basically I add up arguments to my command that will execute every Python file that I do have that actually contains the code that will process data in the pipeline. Same thing for all the components that we do have. And then we do something interesting is that we will load here in the configuration file, in the Python file, we will load the configuration file of Seldon. And that's actually very good because that's how we're capable of using Seldon framework. And then we're capable of calling this resource. So technically, this is a KFP SDK that is calling the Seldon deploy resource and be able to apply the configuration file, which will deploy our models. Here we add up just this attribute, so we can mark down every potential like deployment that we will do later on if you run potentially on schedule or you run it multiple times. Okay, so after doing that, the only thing that is left, knowing that this file its purpose is to be compiled, we will potentially compile this file. Which one is it? Okay, it's in C pipeline. No, it's not in C pipeline. It's in Kubeflow pipeline. Okay. All right. So now we have our output file. You can potentially download it. And now, before going further, and this is a little bit tricky because technically your cluster role is what will potentially contain rules that represent a set of permission for resources in the cluster. So, and that's the thing, if you don't do that, your cell done will potentially crash because Kubeflow will not give you the permission to, like I say, mess up with the resource, but that's what it is. So we need to edit the cluster role for what they call pipeline runner. Now you need to pass the new API group that authorize and give permission for specifically for machine learning pipeline or machine learning cell done. I'm sorry. Now we can go down. Let's add it up at the end. Okay. Indentation issues. Escape. WQ. There you go. The file has been edited. Now, last thing, we want to enable inference. And this is something that I don't like about Kubeflow, but it's good for a certain way, because in terms of permission, you know, it's not a free for all. So it's still a good tool for some enterprise requirement, but still documentation isn't really clear for enabling things, permissions. So you really need to discover it yourself. And I really deeply understand some critical components of the way namespace works and cluster role as well, because if you don't, like technically here, you can't, you're not be able to use the inference module of Celta from the Kubeflow namespace. Okay, it has been labeled. Now let's do a final check. We want to check up our pods, see that everybody's healthy, everybody's happy, everybody's healthy, everybody's happy. Now we have downloaded the file. We can go on the right, then click again, upload. We give it a name, MLOps 123, MLOps test. Then you go on upload. We select our file. That's the right one. And now we click create. Okay, we get this. So this is our complete pipeline. Obviously, it's just a graph, so it's not processed yet. But usually, if there is, that's the thing, if the pipeline or the stream is not healthy, I mean, the pipeline is not healthy, you'll get a warning saying, hey, your pipeline isn't healthy because, I don't know, something in the flow doesn't add up at the end of the day. Okay. We will choose default experiment, but again, you can create your own experiment names and you know, assign runs inside each experiment. Here, that's the thing. It comes with parameters that we have set up before, and that's cool because here we can change parameters that I already created, here. Here, exactly, for the pipeline. You can potentially here set up whatever parameters you need in the processing of the pipeline. Can be volumes, can be things that will be used by the machine learning model. You can specify, I don't know, keep 3 models I wanted to keep just top 3 models, and this will be reused by one of the components to basically create the pipeline. Let's keep everything default, and let's run this. Okay, so our pipeline seems to be good. It's completed. Check if there is any logs. Seems to be okay. Sometimes, and that's something I really don't like about, maybe there is no logs for predictor, but it happens that there is a little latency between the moment you potentially, I want to print out logs, and the moment I will get that information. Based on the research I've did, it seems that it's related to the ingress. I'm not sure of that. So potentially changing the ingress might help. I don't know. But that's something I have seen with Kubeflow. So you can see this is probably the pipe install requirement running, and then probably our Python code running and printing out a couple of things. By the way, I didn't tell you, but you have, for example, you can visualize stuff here. You have access to, for example, visual things that you can visualize artifacts. So let's say, for example, you outputted a rock curve. You will have the ability to visualize the rock curve in the artifact section. And that's something I discovered actually very recently, 2 weeks ago. But yeah, that's a very cool feature to really check, potentially have a look at what's under the hood, because the worst scenario for a pipeline is having an obscure pipeline. You don't know what's going on under the hood, what is the outcome, what is the performance, any processing that go well. And I do believe that Kubeflow is a good tool just because it gives you the ability to have a look at different with these potential tabs that you have here. And if you have any doubt, I always recommend just go in directly, check directly the Kubeflow name, the namespace, or whatever names dependent namespace you're using, but to check the pods, and potentially look for describe use functions like kubectl describe, then enter the name of describe pod and then enter the name of the pod, or use directly logs. Logs is super cool as well, gives you all the logs printed out. Okay, now that we have done this, we need to get the ingress IP address.
I'm sorry, where do you store the models? I remember in your slide.
We use mounted volumes with a persistent volume.
But I remember in your slide, you have an architecture diagram which show you have like a model meta store or something.
No, it's within the Kubernetes cluster. So it's not a proper, that's what I said at the beginning. I said you could use a proper model registry, or you can use S3, for example. But here we just use like a local volume, let's call it this way, for the purpose of the demonstration. And all the data is potentially, because between each component, you reuse data. But here we don't use the data as a flow. So we don't move the data from a component to another. We just save the data somewhere in a mounted volume. And then the next component access that mounted volume to get the data and save again. Then the next one is using what's saved, and he knows what he's looking for, depending on the name, like he labels, cleans, tokens, TIDF, etc., until learning model.
Yeah. I mean, because we have to train multiple times, right? And then we try to get the best version of the model. So we need somewhere to track all different version of model.
That's a very good point. Here we don't have a process for versioning, a proper one. I mean, a consistent one. But you should definitely have one. And that's what I said at the beginning. I said this is just for demo purposes. But technically, you should have a proper registry, a model registry. And each time the model generate, like here, for example, we define like attribute outputs with specific custom name. You might have the same thing for models, where you will each time generate a new unique model name or model version that you will re-upload in Celdon. And moreover, you want to version this so you can re-access this. So if you want to review the version 0.3 of the model, you can access this definitely. But again, we had only 4 hours. So, and my time is always limited these days. So I didn't have really the time to go that deep. And there are 2 things that we have missing here.
So which tool do you recommend to use for model registry?
That's a good question. I can send you a list of open source for that. But usually customer for model registry, they use a lot like S3 buckets for this type of things, which is, I don't know. I mean, you create artifacts, right? From, for example, let's say you use MLflow. MLflow will help you have access to models, for example. But I don't consider MLflow a tool for model registry that we can consider as, it's good for experimentation tracking, but not really for model registry. My opinion, again, I might be like, it's my own opinion, so I might be like wrong on that. But for model registry, really what I have seen is everything based on things like S3, for example, or like I did here, using a persistent volume.
Yeah, but PVC or S3 doesn't have a version control.
Well, you will have to build up your own versioning system. That's a very good point as well. MLflow offers you the ability to version stuff, but is it a good model registry? My opinion, no. But I don't want to go further in that, because I know very well MLflow, but for this version, I don't think I have that experience to say if with the tools, with those two tools, to say if MLflow is really a good for a modular registry or not.
Okay.
As good, yeah. Something that I have seen, because something that I have seen as well is the usage, and that's a good use case, the usage of something like SageMaker for a modular registry. So basically, you just use SageMaker to version potentially your models. So using a portion of the tools, not all of it. Or using commercial solution like Azure ML for Azure Machine Learning for your model registry as well. But for Azure ML, I'm not sure how deep is, how flexible it is for pushing from, for example, an AKS or EKS cluster. So that's the thing. Look, I can send you MLflow. Like here, for example, MLflow, they have a full section about model registry, explaining how they are good at this. But again, I've worked with MLflow, and let's say potentially I want to connect my pipeline to MLflow. MLflow is not supported by Kubeflow in this scenario, but I could create another namespace that will contain MLflow, for example, inside my cluster, and then be able to submit all my experimentation to MLflow, and then be able to do model registry with MLflow. That's a good scenario. I don't see why it couldn't work, and I think that could be a good approach. But again, what I can't give you is my own experience about how good is MLflow as a model registry, because the majority of the customers that I have, even if they use MLflow, they use usually something like S3 for model registry.
Okay.
Awesome. So let's get our endpoint, and let's do an API call. Oh, no. Let's see. Awesome. So our model is up and running. We did a test sending text, and they gave us like a unique ID here. This is generated by Seldon. And we do have, and that's cool, we do have a request path. So we have the ability to track down the module used or the component used here. And all this is deployed on Seldon. So every component, not all of them, we don't use the data downloader, because we don't download data with the Seldon, but we use other components like clean text, because you need, even in inference, you need to clean the text. Potentially you need to do transformation pre-processing, and then you potentially score. And here it's providing us results. This is an output. This is recognizable that it's an output from potentially a neural network with a probability of 1 and probability of 0 potentially.
Just curious, I did not see you deploy the model. How come you can?
Well, that's cool, because I didn't deploy the model. The pipeline deployed the model. That's what the component Seldon deploy is used for. And that's cool.
Okay.
That's awesome. I mean, one of the things that is really annoying is the ability to manage each time the deployment portion by redeploying, redoing a rollout, restructure. Here, it's done by the pipeline. So like I showed in my presentation, here the pipeline will push to the ML engine the models, and will do the deployment. It does two things. It does the initial deployment using Seldon existing deployment. So I'm talking about the core. I'm not talking about the model. I'm talking the core exists. It comes with Kubeflow. And now with the pipeline, I asked Seldon to create the model, microservice and inference model. and potentially to create the other ones that are included, the other components that are included in the configuration file. But the cool thing is, if you rerun the model, if you rerun the pipeline, it will re-trigger the deployment. And potentially the ideal scenario is where it will have a rollout. So you will potentially have a new update of the model without having to change the endpoint.
But for the production inference, do you need to create another pipeline in the down layer, like from data preprocessing to the inference model? Do you need to create another pipeline for this?
Another pipeline for what?
For data preprocessing and then inference model.
Well, here we did them in the same pipeline. We did them in the same pipeline. So the pre-processing has been done here. Clean
yeah,
text.
But this is for training. But what about for the production inference?
Well, for production inference here, you mean for the Seldon machine, ML engine, right?
Yeah, in your diagram,
Yes.
you have a red color rectangle, right? If you go back to your the diagram.
Yep.
Yeah, you see you have a red color rectangle.
Yes,
from
that's
data
Seldon.
Oh, so you mean these two components are in this?
Are in Seldon, exactly.
Oh, okay.
That's why here, if you look at here, it's actually not. It's not two things. It's actually 4 things. It deploy one for one specific pod for clean text, another one for TF IDF, another one for learning, so the classifier, another one for spacey tokenizer, and each one, if you can thank the
because you're using S2I. Yeah, I saw that.
Exactly. Yeah. If you see it in the configuration file, we did the setup. So Seldon know who is communicating with what at the end of the day.
Okay, that's cool.
That's awesome, because this is another level of automation that we can reach. And this is time saver, scalable, so scalable, because I've seen teams where, and that's the thing with MLOps, people, they really underestimate that portion. They think, oh, I deployed 2 APIs, that's cool, now we can scale up. But when they scale up, they realize that the load of what is to handle in terms of models to deploy, retraining to do, components to create, it becomes hard to scale in terms of human resource, in terms of people needed to process all this. So what happens is that you end up with an MLOps where they have so much backlog and it takes long time to go to production properly.
Is this a Seldon inference service a Kubernetes pod?
What do you mean?
If you run kubectl get pod, can you see this Seldon service?
Yeah. kubectl get pods, and obviously we're going to Kubeflow. So you have it here.
So this is the one you're just deployed with the
Kubeflow. It's 15 minutes long, so it's very new. That's in the
Can this one be scaled to multiple pod? Because let's say if we run in the production, if we have a large request.
You mean the scalability?
Yeah.
Oh, it's 100% scalable. That's not a problem. You can scale it. And here, the interesting thing about Seldon, if you can as well add up request limit, you can do auto scaling, or you can do scaling with the Kubernetes command. So basically, it knows when these pods they reach their 70% capabilities, he will start other ones that will handle the load. And this, I can guarantee to you that it's 100% reliable on this with Seldon, because I've seen it in production.
Okay, and this is Seldon production pipeline YAML file. Is this YAML file automatically generated, or you
this one?
Yeah.
No, this one has to be created by you.
Okay, got it. Okay. Then how do you do this retraining?
Well, retraining is by a schedule. You schedule it. When we run here, You go back to pipeline, you create a run, and instead of having one, you have recurring. So that's one way of retraining. You retrain, we could say that based on the analysis we did, we know that with this type of dynamic of the data, we need to retrain once every day. So once every day, sorry, it will process the data and then re-upload the model. But the thing is, you can have conditions with Kubeflow. So you can say that the condition is that don't move to the next component, except if the performance potentially is over, I don't know, accuracy of over 80%. Under 80%, you don't go further. So your pipeline, each time it reaches a step, it will check the condition, validate it. If it's validated, we redeploy the model. So
where do you define the condition?
In here, in the main Python file with the KFP SDK. I know, and I'm sorry, he didn't give his name, but someone has like cell done deploy in pipeline failed. If you want, you can share your screen so we can potentially have a look at what is the error that you're having.
Okay, can you see my screen?
Mm-hmm.
I get this error.
Okay, so if you go right, you would say that cell done cannot access. Yeah, forbidden. You missed one command.
Mm.
Let's see. You missed either the edit cube cluster. Did you did it?
This one?
Yeah, and entered the following section.
This one was to be added in the file, right? Not
Yes.
replace the. Okay, I did this, yeah, as well.
Okay, and the next one, the enable inference.
Yeah, I'm pretty certain that I did this.
Well, because this is a permission problem, like cell done cannot access. So if it's the case, it's either related to the class rule or to your the enablement for the namespace. It's already have a value enabled, so you already performed this.
Mm.
Can you click edit cluster role?
This one?
Yes. Can you make it bigger? Your this side of the screen, please. Yeah. Awesome. Go down. Let's see where it is.
Bottom.
Okay, I have to add this one here.
Yes, please. Copy. Click E. I. Go down, down, down.
Okay. Right.
Yeah. There you go. Just make sure.
Oh, sorry.
Indentation problem probably.
Oh, okay.
Just make sure that the shape looks like the same than the previous ones. Yeah. And as well, there is a non-necessary space there.
Yeah, got this.
Awesome. Now WQ. There you go. It's running. Now go back and upload your pipeline, or create actually a new run. Just create a new run.
Okay, should I run any command now here, or
just go back to the interface. Just go back to the interface of Kubeflow.
Mm-hmm. Oh,
no, it's the other one on the left. Yeah, close this. Go back. Click create run. Choose pipeline on the right. Select the proper one.
Okay.
Experiment. Default. use this experiment. Go down, click start.
Okay.
Now let's see the run. You can click on it. MLOps run pipeline.
Yeah, I think that was the issue with the indentation, probably.
Yeah. I mean, I have seen the error. That's why I know what to do, because actually I figured out that it's something with the permission, did research and find out that it was the cluster role.
Yeah, perfect.
There you go. Now you can follow the rest.
Okay, thanks.
You're more than welcome. Okay, guys, that's awesome. I feel it's like close to the end of our session.
I'm sorry. Can you show me where do you define the condition to trigger the retraining?
Yeah, well, everything. Look, everything for you. I'm gonna tell you something. The documentation, I have seen the documentation for the SDK. It's cool, but it's just a start. You need to potentially discover it yourself. But what I can tell you about the condition, you need to define it in the main Python file. So in your pipeline here, it has to be defined, and I can share with you link about explanation about how to define conditions. Conditions, KFP.
And that condition could be a like a monitoring a model drift. Is that
I advise you to have another pipeline for that. Usually, I have seen a case like this. Usually what you do, but it was not with Kubeflow. Usually what you do when your API is, when your microservice is providing results, when your API is providing output, this output can be collected, okay? When it is collected, you can store it somewhere. Then you can create a pipeline that will get potentially get the data of the model inference done in production, usually crossed with ground truth, because you need ground truth to be able to do it, or at least a specific let's say something that will help you build a metric, whatever it is. And then you create a pipeline on that to check the model each time drift, and potentially inside that pipeline trigger another retraining. So that could be an option. So your source for that pipeline become the database where you store all the data about the inference. But from the same, creating one unique pipeline where you get the data, and from that data, it's doable actually. You could get a pipeline where you get the data. I can even draw it. You get the data where you gather the retraining data. So let's call it data downloader. Then actually here how would you do it? Or yeah, I like this idea. So at the beginning, you will have like let's say you connect to the database with not performance data, but yeah, correct performance data. So everything from that comes from your API microservice. And then here you will have a conditional component that will go look for actually if the performance is drifting. And if there is a drift, then this will trigger other components that will download the data for retraining, data downloader. And then you keep going in your pipeline until you reach the redeployment component that will push a new model to your API. So that's doable to your microservice framework. So that's technically doable. Just more complex, but that's definitely doable. And I like this approach because technically there are two ways of triggering a retraining, either on schedule. And schedule is the most popular because it's the easiest. Schedule is just whatever happened every X amount of time, rerun the pipeline, and you have the ability to trigger on performance. But this one is more tricky because it's harder to automate. Why? Because sometimes this computing the drift is hard to estimate. Why? Because you sometimes, okay, you do inference, but how can you compare it to the ground truth? The ground truth, sometimes you don't have it. For example, I'm going to give you an example. Let's say we build up recommendation systems for our platform. Okay, we have an API. You have an API request and stuff like that. It's going well, but now we wanna know what is the performance of our models. How can you know what is the performance of what is the ground truth when people click on recommendations? Is it did people click? Did people not click? And that's not even like the ground truth. That's more like knowing if the product you pushed is popular or not. And all this make it difficult to build up this specific component. But usually you can use a bit of business, what I call business metric, like or context metric. Like instead of using the ground truth, you will use, for example, if people have clicked on your product, and you collect this in this database, and then you reuse that to be able to compute if there is any drift. For example, I don't know, you realize that this week your average click on item at the beginning was at 35%, which is you consider as good, and now it's only at 15%. So this means somehow that your model or what your model is providing as a recommendation is not considered by users as good anymore. Users, they want something else that you don't offer yet. So this is the type of approach. But drift, to be honest with you, people, if they don't go with this very often, it's just because it's a bit more complex. So schedule is less headache for people. But definitely in some cases where, for example, you have mission critical systems, a drift is very, very, very important, and you're playing on a very tight like delays for whatever it is in terms of performance. You don't want to wait for the schedule. You really want to make sure each time there is a drift and you go under a certain threshold, you want to trigger the retraining.
And for the condition, you said we can check the sample code from the KFP SDK.
Yes, I'll send you the documentation for the KFP, but as well a use case for how to use conditions, because definitely that's something of interest that you can use to build up. But there are other ways you can potentially perform that, because you can put a condition on the execution of the upcoming like components, or in the pipeline code, you can run it in a way where actually you don't send any more information to the upcoming components, which is equivalent to condition, but I rather use the condition method in the SDK KFP for doing that.
Yeah, I understand. So we can do a condition with our regular Python code, or we can call the KFP SDK to do the condition.
Exactly, exactly. But the condition with the SDK is more sustainable because it doesn't, if there is a condition and it's not met, it doesn't allow the upcoming components to run. So it will just stop, which is actually a good practice at the end of the day, instead of running the rest on blank with no data potentially.
Yeah, I saw there's a function called condition in the
exactly. That's the one.
DSL, right? Yeah. Okay.
Awesome. I know Sunday is, I feel like Sunday is a good day to learn new things, guys. I don't know what's your own feeling about that, but I feel we were quite productive today. Awesome. That's good. I hope you were satisfied of this. If you didn't understand everything, like, don't stress out. Like, focus on first learning the KFP SDK, because that's the key thing here. You have access to it. You have, I sent the link to the documentation. No? Or do you can you download it from your site, guys? No answer? Can you download it from your site?
Which one?
I think the documentation, but let me do that. I'm saving it in a Word format, and I'll okay, you cannot download it. Let me see if I can. Where are you? There you go. I sent the file on the chat. You have access to the file now. And use this, try to use this as just a basement for you to practice, and then start building up like more custom pipelines. I can tell you that with this type of open source tools, there are documentation, the guidance is good, but sometimes when you do complex things, you'll not find like a documentation about your case. So you might have to ask questions in forums, hoping that people or someone with good knowledge might answer you. Awesome. Any other question or comment or note you want to share before we end up this session? Any communities? That's a good question. You have the GitHub really. Oh, for ML learning. For ML learning, well, you have. This is top for learning and sharing with others. Kaggle is really a must. One of my favorite teachers is this guy. In machine learning. And yeah, you have other sources as well. Unfortunately, I forgot the name of one of them, but Definitely, if you're looking for more information about this, I advise you guys to send me an email, and I'm writing my address. I will be more than happy to help if I can. You can as well add me on LinkedIn. I'll send you my LinkedIn right away. I post a lot of things in data science, machine learning, and MLOps. So follow me and send me a connection request. We can definitely have a chat and discuss some more things like Kubeflow or any other tools, commercial solution as well. Because I mean, it's MLOps, it's an underestimated field today, in my opinion, based on discussion I'm having with people. But it's a field, believe me, with so many opportunities, so many tools to learn. I do believe that I master maybe 10% of the existing, not even 10% of the existing tool. I know probably 40% of the existing tool. And I mean, so many solutions, so many things you can do with it. And each time you have new solutions that pop up, etc. So yeah, if you don't have any other question, guys, we will stop this here. And again, I sent my email and my LinkedIn. So please reach out if you have any question. Thanks a lot. Thank you, guys. It was awesome. Thank you.